Hi John, this is Alexander again. I've made a few updates to the code since the last screencast, so this is just to fill you in on the changes that have been made. Like I mentioned in the first screencast, I had an idea of changing the clear wall to the same way that you use resize, so this did actually work well for me. Um, Now, instead of just clearing all the spaces and send them to zero, which isn't technically emptying them, this creates a new array and then deletes the old one and sets the new one as your main array. So this will create a new array of the same size, but they'll all be empty. So that works well. I'll showcase all these working afterwards when I'm finished explaining them. The pop and remove had to be changed around because the pop was essentially just calling the remove at a certain point, and the remove was removing something, but it was cloning what was after that. So if you removed number 8 in an ordered array, it would replace it with number 9, but then where 9 was originally where there would still be a 9, it was cloning what was after it. So I set up another version of the resize function for my pop. This seems to be the best method for working it the way that I have everything set up. I know other people just used a num elements function, but I've set my thing up differently, so hopefully this will be the most efficient way. Um, what this does is it just makes another new array, but this time sets its size to -1 of the original size, then fills it with the originals, and then just deletes the original and sets this new one made the same as the resize and the clear wall. So an example of this would be if you have an array of size 10 and you use the pop function, which takes the last element off the array, you now have an array of size 9. So this creates a new array of size 9 by doing the -1 here, then goes through a loop to fill the new array with the first 9 elements of the old array, and then once that's done it just deletes the old one, sets the new one to your main one, and such. The remove function then again does the same thing that it did originally. It'll remove wherever you've indexed the location at, and then push everything down. That just means that the last element will be a clone of the second last one. You'll have a duplicate of the last one, so it just calls the pop at the end here to pop off that last duplicate that you don't need. The next thing I changed was in read unordered. I just forgot an important line. Num elements here has to be set to 0. This is because what the read unordered is doing here is it's calling push function, and push sets it pushes in the new data to the end of the array. So what this was doing was it was just pushing all the new stuff that it was reading from the text file onto the end of an empty array after it was cleared. So you'd have the first few spaces of the array completely empty, and then it would be resized to add in the new stuff. So you just have to set num elements to 0 here so that it will fill the array from the beginning from point 0. Binary search had to be changed because though it was working, it wasn't always working. It was skipping certain numbers or well, index spaces, specifically the first, the last, and the middle, the very first middle space of whatever array that you were trying to search for would never show up. I tested this using an array of 10 spaces and tried call the binary search on all of them from 0 to 9, and it was able to find all of them except 0, its first one, 9, its last one, and 5, which was the middle one. So this method is just a bit more effective, and it makes sure that it can find everything. And same basic idea, now has a max and min as well as the iterations and its index and a boolean. It sets up a while loop against the iterations as long as they're less than or equal to the maximum iteration that can be possible, and as long as the boolean found isn't true. It'll just keep setting the index here and searching the index against the input. If the input is found, then set found to true to break out of this, and the iteration to max it or to as well. Yeah, I could probably do without that line, but better safe than sorry. Um, that'll bring you down to here, and if it's found, then you'll just get the same output message. Otherwise, if it breaks out here on its own, then you'll get the error message. Yeah, sorry, as I'm saying, if input is the same, it'll say found. If it's not, and it's higher than what the current index is, then the minimum becomes the new index, and the iteration starts again, and it loops over again. If it's otherwise, it would mean that the input is less than the index, so the maximum becomes the index, and the iteration goes over again. This is much more effective, and I found that it does actually search everything. I again tested it with an element or an array of 10 spaces and searched for all 10 elements, and it was able to find all of them. So the only other thing I changed was timer code. I got time code from Lucas Pontiff in class. Again, if this isn't the fully correct method, then uh, let me know and I'll fix up the new ones for ca2 and 3 if they're needed. But yeah, this is all just the code that Lucas Pontiff given me, and so the only change for that has been, where is it? Sorry. Oh yeah, when I'm searching now, just set the timer to reset just before I do the search, then do the search, and then timer get millisecond, and then reset it again. And I did that for both searches here. So I'll just run this and show you the few differences that we made. The first one, you can see the num elements now, or sorry, the read unordered. Now that num elements was set to 0, the first spot is being taken up. Now beforehand, the first like up to 9 were just full with jargon data, and it would just resize to fill up all the rest. As you can see now, clear all has emptied it and just filled it with all this jargon data now, so, or garbage data, whichever you prefer calling it. The searches, as you can see here, search for element, the linear search, the time given is 9 milliseconds, and the binary search, time given is 6 milliseconds, so still the binary search is still much more effective. You can also see that the binary search is actually working correctly now. You can test this as well if you feel necessary by using larger numbers or a larger overall array size. I tried as well a few thousand, and it was able to find every number that I searched in it, so that's quite helpful. Oh yes, the pop and the remove then. So here you can see the last few things that were inserted would be here. So we have 0 to 9 in the first 9 spaces, then 78, 145 and jargon. The pop function has completely removed the last one, so it's now 12 spaces. And the remove function, which is called for number 4, is gone, and they're gone. It's gone down to 11 spaces. Originally the problem here was that it would still have a 12th space here, number 11, and it would equal to 145 as well, so it was cloning itself. But that's all being dealt with. Okay, so there are the updates that I did on the project. Thanks for listening. Sorry for the amount of screencasts.